Today's lesson is on regression. It's lesson 1-4. We'll just kind of go through the topic quick, and then I will actually get to the TI emulator is what it's called, where you get to see the calculator on my screen here. So what we talked about yesterday in class is this idea that we may be given a specific set of data. So years and amount of rainfall, or the first example we do is distance from the center of an earthquake to the time it took to feel it. And then the idea is if we plot those given data points, we need to find an equation that represents that data so that we can then interpret other points of information. So what we talked about was these four here. The linear regression is it's actually fairly common. In this case, data points you see look more like this hook. It kind of goes horizontal and then it all of a sudden goes vertical. So the idea here is you're trying to estimate what that graph would look like with a straight line. And what happens is this R value, which is basically what the R value represents is how accurate is your equation line to the data? How well does it fit it? So your target is exactly 1 or -1, depending on what regression it is. But the idea is to get R as close to 1 as possible. So if we look at a quadratic regression where they came up with some equation that is quadratic and they tried to fit it across our data. And again, you can see 0.94 is good, sort of, but visually you can see it's not perfect. So exponential regression, as you can see, when we fit that curve to our data, first of all, the R value is very, very high, but visually you can see it works really well. And our last one that we can try is a logarithmic regression where it tries to fit a log function. And in this case, it's almost the inverse of that, right? Where it's the arc is kind of going from vertical to horizontal as opposed to the data points, which are the opposite. So our goal is to take sets of data and try and fit equations to them. So let's get started. The first thing, and I will actually have to go through every step because I just got this emulator on the computer, is to make sure that you have the diagnostics on. What this is going to do is turn on the function that actually tries to create equations based on data. So it says go catalog, which is second button and 0, and then find diagnostic on and hit enter. So here's what we're going to do. Here's my screen. Hopefully the calculator on the left is big enough you can see it. But what it said was to go to second 0. And over here on the right, you'll see the commands I'm using. So second 0, now I'm supposed to find diagnostic. This is alphabetical. I can either scroll from A through D, or I can jump. If I can find the letter D in my calculator, where is it? Oh, we'll just scroll. Maybe. This is gonna take forever. So here we go. As you can see, I didn't get very far after 15 strokes. So I'm gonna go alpha, and the letter D is x to the -1. Okay, that should have jumped us there. Let's try it again. Alpha D. There we go. I don't know why it didn't work the first time. So at least it's jumped us to the D categories for diagnostic on. It's gonna take a minute, sorry. There we go. So there it is, diagnostic on. We scroll down, we hit enter, we hit enter again, and then it ran the command to put it on. So we can clear that out. Okay, so back to what we were doing. These are our data. Data says travel time from the epicenter of the earthquake. So from the start of the earthquake, how far are you and how long did it take to get there? So what we need to do is add this information into our calculator. So here it says type in the data, stat, edit, type your data in. So we're going to take L1, which is column 1, you'll see here in a second. That'll be our X values, that'll be our time. The distance traveled, the 400, 800, and so on, that'll represent our Y, which is going to go into column L2. So stat, edit, and then the number 1 looks like this. Let's see. The stat button right here. And then edit is right here. It's already the one we're selected on. You can either hit enter or you can hit the number 1 because the number out front. And it gives you your lists. So we need to enter all of that data. So in the L1 column, we're going to enter that information. So 1, enter, 2, 5, 7, 10, 12, and 13. I think that's right. I'll double check that. But then you just hit the over arrow, gets you to L2, and then from there we can actually add the Y values. I'm going to pause the video because there's no reason to show that. But let's get like 400 to enter and so on. So let me pause that and I'll enter. All right, there we have it. We've got our data inputted to the L1, L2. All right, I'll try to hurry. So now we have our data in. We need to go ahead and graph that data. So in order to do that, here I'm going to pause. Okay, I got to pause because I'm not really sure where I left off exactly. The bell rang, classes were switching, but I'm going to regroup here and say we were on step 2. We're trying to graph the set of data that we have, L1 and L2. So we now have what's on this screen right here. What we need to do is plot it so that it looks like the dots on this graph down here. So a couple things we got to do. We go back to our calculator. So go to y equals. We just jump right from our L1, L2 data, the y equals. Just make sure they're all cleared. Everything's empty. The notes handout you have actually said to go through like a 3-step sequence to turn on the plot. What I'm going to tell you to do is from the y1 equals, just go up arrow. While your cursor is flashing on plot 1, hit enter. And if you come back down to double check, it now has a dark background. That is essentially what step 2 is sort of telling you to do, at least step A, B, and C. So now we actually have the plot turned on. The problem is if I hit graph, it says that I'm looking at -10 to 10 in both directions, but my data starts at 400 and 800 and goes on. So we need to zoom out. The fastest way to do that is hit zoom. And we have lots of options, but because we're using statistics and regressions, we can actually go down to number 9. We can cursor down. Or honestly, anytime you have a selection like this, I can just go number 9. Okay. What zoom 9 does is it figures out the highest X value, highest Y value, and lowest H, and it turns your window into a window that fits all your data plots. So now we have our A, B, C, D, and E. Ensure all data is represented correctly. So we now have step 1 and step 2 done. We are almost there. Step 3 says, now pick a regression model, which means you are being asked to find an equation that fits the data. So at this point, it really is sort of a guessing game. We have to go back to our options and say, based on the dots that are on our screen, do the dots look like a straight line? Do they look like a quadratic, an exponential, or a logarithm? So from what I can tell, just looking at the data, I would say it kind of looks like a parabola. So we're going to try and fit this to a parabola. So to do that, the steps say we go stat, and instead of editing or sorting anything, we have over arrow, because we have tabs up along here. Okay, we can test things, we can calculate things, and we can edit them. We want to calculate a regression equation. And if you go down far enough, if we thought this was a straight line, we would try and fit it to the linear regression. It even tells you it's the form AX plus B. We thought it was a quadratic regression. If we thought it was any of these other ones, we would go down and hit enter. But for now, we think it's quadratic. So I'm going to hit enter the quadratic regression. We are asking it to make our list L1 all of our X data, L2 is our Y data. So all we're doing here is we can just hit enter through each of these options. We don't need to recheck anything. We get down to calculate and you hit one more time and boom, there it is. All right, perfect. So this is saying the equation that we're coming up with is the standard form A squared plus B. The A coefficient is this, B is this. The other important piece is the R squared, and that's that correlation coefficient, right? So we want that to be as close to 1 as we can, and I think a 0.998 is pretty darn good. You could go back, try other models, and see if other models work. But what you'll find is that 0.998 is the highest you'll get. You might get a 0.86 something or a 0.5 if you try like a linear regression. So what you're looking for is the highest R squared number. So now that we have that, we have two options. We can either write those numbers down on a sheet of paper, copy them down, go back to y equals, and type them all in manually. 36 whatever x squared plus so-and-so x plus c. Or we can let the computer or the calculator do the work for us. And that's where this says manually copy down the equation and type it in, or automatically, and there's a sequence of button presses. So let's do the sequence of button presses. The easy way, the copy paste method, is to take and hit vars. First of all, make sure you're at the y1 equals. Please make sure you're not on the equals sign. Okay, we are not over on the equals. We're over here, ready to enter stuff. We go over here to the VARS, the variables or vars button, and we're looking for statistically, we're looking for the variables we just used. So we go down to 5, and we enter. Now we're looking to input an equation, so none of these individual variables work. We're not doing summations, we're actually doing an equation. And look at that, number 1, the regression equation is our first option. So we just hit enter and pops up our equation. So our screen now says y1 equals 36 squared plus 64 whatever x. And it also allows you to keep all those decimals. Most of you would just copy down 36.6, 36.2, or 62. But here it actually carries out all the numbers after the decimal. So we have our plot, we can hit enter, we can hit graph. And at this point we are confident that we have the information needed. So if that's all it's asking is find the equation or the regression line, what you would actually do, your final answer would then actually be typing, like writing down the answer, 36.6 x squared plus 264 whatever x plus the last number. So your answer would actually be that. But for this activity, I think it's just asking us to, it's just to find, use the data below to determine a regression model. So right there, find the equation. So your answer to this question would be that equation. Looks like I'm at the end of this video. I only get 15 minutes. So I will do example 2 very briefly in the second video here in a moment.